Hello everyone. Today I'm going to give presentation about Futoshiki Puzzle, also known as more or less puzzle. Introduction. Futoshiki is a logical puzzle. It is from originated from Japan. The word Futoshiki itself means inequality or not equal, which refers to the main element or the component of a puzzle, which is inequality constraints. It was originated from the Japan in the year 2001, and it combines the elements of Sudoku and inequality constraint to create a unique and challenging puzzle solving experience. Objectives of the project. The main objectives of Futoshiki is to fill a grid with numbers typically ranging from 1 to n, where n represents the size of the grid. The goal is to ensure that each row and column contains unique number by satisfying the inequality constraint. The goal is to solve the puzzle by deducing the correct placement of the number based on the given clues. Solving a Futoshiki puzzle requires a combination of logical deduction, pattern recognition, and elimination of possibilities. Player needs to analyze the relationship between numbers and use the given constraint to narrow down the potential solution until they find a unique array element that satisfies all the rules. So there are different methods to solve the Futoshiki problem, which is the most commonly uses force min-max. And chain inequality, number exclusion, min-max exclusion, and double and triple technique. So, next overview of Futoshiki. The overview consists of grid structure, inequality, initial clues, and variations and complexity. So let me show you an example here. So this is how a Futoshiki puzzle looks like. The pattern you're looking called is as it is called a square grid. The Futoshiki features a square grid usually with size ranging from 4 to 9. Although the size can be also can the size can also be found in different numbers, is going to increase the complexity of the puzzle. The grid is divided into rows and columns, creating individual cells for number placements. Uh, Now let me explain this inequality constraint what it is. So one distinctive aspect of Futoshiki puzzle is to inclusion of inequality signs. Here you can see the arrow marks here. This is called as inequality constraints. These signs indicate the relative order between adjacent cells. The objective is to satisfy these inequalities by placing the numbering correctly. Look, the initial clues. Futoshiki puzzle come with a set of initial clues, pre-filled numbers scattered across the grid. These clues is the task. These clues serve as a starting point and provide some initial relationship between cells. The solver's task is to use these initial values uh, to find the relationship between the cells, and solver task is to use these clues as a foundation for reducing the remaining number placements, variations, and complexity of Futoshiki puzzle. A Futoshiki puzzle comes in various levels of difficulties, ranging from easy to challenging. Some variations of Futoshiki puzzle may incorporate additional constraints such as diagonal inequality or irregular grid shapes, adding an extra layer of the complexity and variety to the game. So let us solve this simple examples. Here they're going to once again. Here you can see we have initial values such as 2 and 3. They show a symbol which this particular block is less than 2, which means as you can see it's a 4 into 4 cross matrix grid. The one is less than 2. So here we place the value 1. Since you can see there's a 3 in this row, there's a constraint that states that cannot repeat a single number in the same row or column. Each row and column should have different values. So we cannot have 3 here. So 3 in this row. So the larger number than 2 is 4. We add 4 here. And as you can see, the only one value which is missing out in this particular column is 3. So we add 3. Um, if you come to this row, you can see that the 3 is the smallest value, and this particular block value is greater than 3, which means the number here should be the maximum value. And the matrix of since it's a matrix of 4 into 4, 4 is the value comes here. And since 1 is here and the number should be less than 3, we all know that the value we're going to enter here is 2. And as you can see, the now value left out in this particular column is 1. So we end up adding 1 here. Since you have seen that the whole value has been entered for this row 4 and 3, we state that the particular value should be greater than this value. And since we have entered 4 and 3, which is greater values, it is obvious that the value we are going to enter here is 2. And the value left out in this particular row is 1. And this states that this particular block is greater than this box. As I say, always since the 2 has been done, the maximum value here is 4. So we are going to add the value 4. Here the value which is being missed out is 3 in the particular row. So we are going to add 3. Mm, So in this particular row, we cannot repeat uh, 3 in the same column. And so does 1 and 2, because it has been placed here. So we are going to place maximum value, which is 4, and the particular value left out in this particular column is 2. So I'm going to add 2 there, and the value left out in particular row is 1. So we are going to add 1 here, and the value left out here is 3. So this is how we solve an Futoshiki problems. Here you can see each row and column have different value, unique values. So 1 2 3, so 1 3 4 2, 1 2 3 4, 3 4 1 2. Look, no value is being placed 3 corresponding to each other. 3 is there and 3 is here. It's not next to the particular value. Yeah, from here onwards, my other teammates will explain the presentation. Thank you.
Complexity and time complexity. Like in the beginning of this algorithms, we'll have to define the which data structure we'll be using for the puzzles. Like in our code implementation, we have used a different class for each style and different board for each board. Like each 25, like 5 cross 5 board will um, contain 25 tiles, and this board is used for further calculations. Coming to the next step, like initialize the board by assigning initial values to some tiles and leaving other empty spaces. Like as Divya said, the puzzle will be initialized by some of the values, like clues or some values will be given in the input. Like we can see here, for example, in this board we have three at the top right corner, and the bottom left corner will be having a 3. So these numbers are fixed, and we will initiate those numbers with the constraints involved in that. Then apply the next step will be applying constraint propagation techniques such as forward checking to reduce the domain of each tile based on the initial values and constraint. Update the domains of the tiles accordingly. Like as I said, like we will be having the constraints, like we have a horizontal constraints like less than or greater than symbols for the rows, and for columns like within the columns we have greater than and less than constraints. So applying this to the board on or the initial values, we will check, we will reduce the domains like we have a domain of 1 to n numbers, so we'll go on reducing the domains such that each time will decrease with the domains, and one each tile will be left out with one value. Then sort the tiles based on the heuristic approach. Like here, as I said, we are using minimum remaining values approach. It is a heuristic approach in which we go on decreasing the domain count. Like if I have a value from 1 to n, I check the constraint. I check the constraint and see whether this number is valid or not. I select those tile which has the least domain, like the domain which as I said in this input, if there is a constraint for this style, if I get a number which can only like only five number 5 can be placed in this tile, so the domain of that tile or the cell becomes only one element. So I choose this element and fill that tile. To make it to make other domains, like I'll be removing this from other domains. Coming to the next step, like backtracking algorithms. First, I'll check the domains. I'll assign a domain for each tile and check what are all the numbers I can fill. Then I go for backtracking step. In this backtracking step, like which I check if at that stage after the forward tracking, I check whether this cell or board is completely filled. If it is filled, I go for the next checking of the constraints. Like if the puzzle is solved, then the output will be true with giving the output. If it is not solved, it's check for the like empty if empty tile is present, like if one of the cell is not completed, it go on repeating for the filling up the cells. Then iterate over the domain of the selected tile and choose a value. As I said, like least domain value, like least domain value will be chosen, and one among the domain will be added to the tile. And then from the top to bottom, the program runs from the top to bottom of the board, and from the left to right of the board. It goes on filling with the domains. Then it checks for the equality constraints and the filling up of board. If all those constraints and the equality I mean if the cells are completely filled, it will produce the output. If not, it go on again backtracking. This backtracking and forward tracking will be mixed together. It checks for the backtracking. If not, if this case does not satisfies the condition, it erase all the it undoes undo the all the steps. Like it backtracks to the position where the forward again we start for the recursively we go on for filling up the cells as with respect to minimum remaining values heuristic approach. So this is the algorithm for this puzzle. Coming to the time complexity and space complexity, at the simple or least case, it is n into n, that is n square time complexity, and at the worst case it will be 2 power n square complexity, which will be heavy, which will be very high for the computing. It depends on the problem method and how what heuristic approach we are approaching with the problem. So coming to the space complexity, it is usually n cross n complexity with storing all the values of the cells. But in our program, we have implemented with the nodes, like for a particular cell, we have a class, we have defined a class, and for a particular board we have defined 25 tiles for each board. So this might increase the space complexity. As we need to compromise with the space complexity, we increase the time complexity by reducing the time complexity of iterating the whole array every time. So we have used a board class which specifies each tile with a name, like t11, which specify the first row first column element, then t12, like the second element of the first row. It goes on specifying till the 25 tiles. This lead to the easy access of the each tile without iterating the whole process. This is one of the optimized way to in our program. So in order to having a good time complexity, we will compromise with the space, having with each tile defined in each board. So further will be continued by other team members.
Hello everyone. Now I'll be explaining about the benefits of playing this puzzle. Now, playing this puzzle offers a range of benefit which contributes in the development of our it enhances our critical thinking, logical reasoning, and many problem solving skills. And it also requires analytic thinking so that the ability to make deduction based on the given constraints and improve the cognitive abilities uh, to the entire time and overall well-being. And coming about talking about mental stimulation, engaging this game also provides a good mental stimulation to the human being, and also it gives a great challenge to the brain. The puzzle also requires concentration, attention to detail, and the ability to think ahead, keeping the mind active and sharp. And also it enhances our memory. Solving this puzzle involves remembering skills and all kind of activities, and deduction made during the solving process makes our brain sharper. Regular practice improves memory retention and retrievals, benefiting overall memory skills. Next, by playing this game, the stress can be relieved, and it leads to relaxation. Engaging the Engaging this game can serve recreational activities, offering break from daily routines, providing source of relaxation and enjoyment. And even this leads to continuous learning, like playing this puzzle, solving in our free time and all gains us new insight, strategies, and new approaches towards the game. And it improves our solving skills, also encourages growth in the mindset. Next, I would like to talk about the conclusion of this report. These puzzles offers captivating and intellectual stimulating experiences for puzzle enthusiasts, and this logic-based puzzles game has the unique combination of number placements and inequality constraints, challenge to players to employ the critical thinking, logical reasoning, and problem-solving skills, as it was the advantages of playing this game. And by regular playing this puzzle, individual can experience the benefit which I told you earlier and enjoy the mental stimulation activities which promotes the cognitive development, logical reasoning, and relaxation. And this puzzle also offers the delightful blend of challenge, entertainment, and cognitive exercises that can be enjoyed by the one who will be solving this puzzle. Thank you. This is what we have done.
uh, we'll be showing the implementation part of this program. Like I have told earlier, like we have a different set of classes for defined for each style. Like each style will be representing the cell of the board, and that board contains 5 cross 5, like n cross n tiles. Uh, this is a class defined for board. And then as I said in the algorithmic process steps, uh, first we take the out of first here we are taking the input from a file, and then processing it. First we go on checking its data type, and then data type. And uh, here, as I said, first, we'll take the input of entire numbers, like predefined numbers, or any clues which will be included in the game. So parts this part is for the just the numbers which will be included in the game. Then this comes as the horizontal constraints. We have defined it as horizontal constraints, where uh, here horizontal constraint defines that whether the right side or the left side element is constrained to this element. Like this element will be constrained, will be lesser than the other element, and this is a vertical constraints which defines the lower element should satisfy this constraint. So running to the program, we have given three inputs, like input 1, input 2, and input 3. uh, we will have will be getting outputs in the file format. Like it will produce a files, three output files for a specific input which we have given. So we can see here, we got output 1, 2, and 3 for a specific input. Like for input 1, we have got output 1, which we can see here. We have constraint greater than symbol, which says that this element should be um, this element should be greater than the right side of this element. So it satisfied the condition that 2 is greater than 1. Then the next will be, here we have a predefined clue or number which says the right topmost corner will be 3, 3, then the bottom will be 3, and then 1. And also we have the constraints, like um, 1 should be, here we have 1 here, sir. 1 element 1 should be, the element present in this box should be lesser than the element in the for to its right. So we have seen that 1 is lesser than 3, and it also satisfies the other conditions, like here the fourth row third column should be greater than the element below that. We also have other outputs for inputs, like for input 2 we have output 2, which also satisfies these constraints. We have seen that the other predefined values for those specific cells are same as it is, and others includes the third row first element, where third row first element 2 should be lesser than the right side element, and then 3 should be lesser than the fifth element, I mean the fifth 5, the right side cell. uh, in the same manner, we have vertical constraints, which shows that the number in this cell should be greater than the number which is below that cell. It satisfies this condition. And even the fourth row second element, this element should be lesser than the element which is below that. So this is the way the uh, puzzle uh, puzzle actually works. Okay, thank you.